All right, greetings and welcome, class. This is Mr. D talking to you about measurement. First off, the golden rule about measuring is you always have to go one decimal place more than the instrument has, one place more than the tool shows, every time, always, and only. This tells us the quality of the tool that was used to get the measurement. There is no estimation for electronic devices because whatever it tells you, the estimation's already baked into it, so just whatever the machine says, write down. For liquids, you have to watch out for something called the meniscus, or the bulge that the liquid does, either up or down. Typically, this uses water, and water bulges down. You want to measure at the very bottom of that bulge and not at the top. So bottom, yes, top, no. Also, you may have to measure mercury. So there's water, there's mercury. Notice the water bows down, the mercury bulges upward. So meniscus down, measure the bottomiest bottom. Meniscus up, measure the tippiest top. Every time, all the time. Wherever the bulge is where your estimation has to be. Down for water, up for mercury, whatever direction the bulge is in. Whenever you get a new tool, you want to identify the units that it uses because without units, your measurement is pretty much crap. You need to have units. Units are important. You need to see what place values the tool actually gives you, first in the numbers and then the dashes. Typically, the numbers will be in the tens place or the ones place, and then the dashes will be one place beyond the numbers. You then need to figure out the place you estimate because you always go one further. If you look at these two rulers, which of these rulers is better and why? I'll give you a minute. Did you figure it out? If you look at these rulers, you'll notice that ruler A doesn't have many dashes. No, 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 no. It has a midpoint, but it doesn't have all the dashes below that ruler B does. So ruler A is clearly not as good as ruler B because it has more dashes and thus is more precise and more reliable. If we take a look at just ruler A and we measure it, we can tell that it is definitely above 2 centimeters. The tool tells us this. We then have to go a step further, always one further. So the ones place was given to us as 2 centimeters. We need to go to the tenths place, or 1 decimal place. Now, considering that the halfway point is right over here, our line is less than half of half. So if halfway is 5, half of half is 0.25 or 1/4. We're more in that area, a little less than that. So something like 0.2 is an excellent estimation. 0.1 would work, as would 0.3, although 0.3 is a bit harder because it's not quite as close. So you could do it, but it's not as good as 0.1 or 0.2. If we use a better ruler with the same copy and pasted nail, we see that the tool says it is 2.1 centimeters. Again, more evidence that our estimate should have been a 1 or a 2 and not a 3. However, we now have a better tool. It tells us 2.1. We still have to go one place further. If you look down here, you will notice that there is a little space after the line, but lots of space before the line. That means this is not halfway. No, it is not. It is actually beyond the halfway point, which means it must be beyond 5. So something like 7 would be a good estimate. 6, 7, or 8 would be good, with 6 and 7 being the best for your estimate. Now, we have 3 rulers, A, B, and C, and as you can tell, they get better as they go. A has no dashes or even ones place numbers. B has no dashes, but it does have ones place numbers, and C has both dashes and ones place. This will affect how many decimal points we can rely on for each of these. We're just going to look at A for right now. This is a line, and this line is clearly below the halfway point, and it is clearly below half of half. So again, our estimate is going to be below 0.25 which we can't do anyway because there's literally only the tens place. And since there's only the tens place, our ones place is our estimate. So 2 is a pretty solid estimate, being 2 centimeters, because the tool does tell us centimeters at least. There's at least that foregoing for us. With a better tool, we then have one more decimal that we can give. The tool definitely says 1 centimeter. It doesn't quite get to 2. If you notice here, the empty space before is less than the empty space after, which means definitely this is less than half. So it's less than 1.5. So something like 1.3 is good. 1.2, 1.3, or 1.4 would be just fine. If I make the tool even better, again, with these dashes, we get a whole nother decimal place, which means it's 10 times better than tool B. And we can see that it's definitely 1.1, 1.2, and 1.3 is what the tool tells us. But if we look there, and we have to kind of really look closely, you will see that it's not right up against the line, as there is a little bit of white space there, but there's way more white space after. This means it is definitely less than 5, but it's not necessarily 1. So something like 2, 3, or 4 would be perfect for this measurement. Yes, measurement has some leeway. Yes, it is also very nitpicky and you have to be careful. Decimal places are the most important thing. If I have this red line appear here and I estimate and I measure, I get 4 centimeters for A. Can you figure out B? It's going to have 1 decimal place. The tool tells us 4, and the estimate then would be something like 0.5 since it's right there in the middle. If I look at C, you will notice that that line is smack in the middle between these two dashes. And notice the trick the ruler does. Little line, big line, little line, big line. But the little line seems to be missing because our line is right over it, which means it's directly on that little line. So that would be 4.5, 4.1, 4.2, 4.3, 4.4. Here's 4.5. But if it's right on the line, what do? We know we need another decimal point. Blue proved that. But you have to remember, 0 is a number. It's going to be a number you use 1/10 of the time. So yes, you should totally use 0. 4.50. Now let's look at another line. This green line. This one's a bit trickier. See, if you remember that decimals are based on the tool, then you should be able to figure out the 3 answers to green. I'll give you just a minute. Feel free to pause the video if you want to have even more time to try to figure out A, B, and C. Okay, we are now going to go over the green line. As we can see, it is clearly on the 8, both if we cheat and look at the higher tools, but even our estimation being, slightly more than half of half, slightly more than 0.75. We definitely get 8 centimeters, then 8.0 and 8.00. Look at those zeros. Those zeros are necessary. They are important. One could even say they are significant, and they matter because they come from a measurement that we can trust. More zeros after that decimal tells us just how trustworthy that number is. But we have to make sure that we get it from a tool that actually gives us it properly. So just be mindful that the tool determines the decimal place, which determines the trust. And trust numbers are significant, which is very important in the higher level chemistry classes, whether academic, honors, or AP, because trusted numbers are the ones we are going to rely on. If we look here at this ruler, we have 4 colors: blue, violet, green, and red. And they're done in order. Blue is the easiest, then violet, then green, then red. Red is always the hardest. We're going to do 3 different tools. This is the first tool, which is a ruler. So when you look at this ruler tool, can you figure out the 4 numbers? The blue, the violet, the green, and the red? Hopefully you can. Now, when we look at it, the tool does tell us numbers, the 32, 31, and 30. So the numbers are not just in the tens place, but the ones place. This means that those dashes are the tenths place, meaning 1 decimal point. So the tool is telling us tens, ones, and it's telling us a decimal, which means we have to go one further. Our numbers here will have 2 decimals. Take a minute and see if you can figure out these 4 measurement estimates: blue, then violet, then green, then red. Pause the video if you want more time. I will give you only a little bit of time in this video where I am not talking. So pause it if you need more, and then resume it when you are ready. All right, let's take a look at this. For blue, 31, definitely over 31. 31.1, 0.2, 0.3, 0.4, 0.5, yes, definitely 31.5. This line has more space below it than above it, so the last digit will be over 5. So 31.57 is fantastic, with the 7 having a little bit of flex. It could be 0.56, it could be 0.58, but that's the gist. That's what you want to do. For violet, we've got 30, 30.1, 30.2, and then again, more blanks below than above, but slightly less than we had before, but about the same, so close. 30.27, 30.26, or 30.28, with 26 and 27 being even better. Now green is right there on the line, so you might think, well, Mr. D, that just means it's 32. But remember, everything here has 2 decimals, so it's 32.00. The tool determines the decimals. Now red is again right on that line, so that can trick a lot of people. So it's definitely 30, 30.1, 30.2, 30.3, 30.4, 30.5, and that's right there on the 0.6 line. Notice that should be a long line here, but we can't even see it because the red line's over top of it. So this is definitely 30.60. Notice all of these had 2 decimal places because that is what the tool tells us. Now that was a ruler. Let's look at a thermometer. Again, blue, violet, green, and red. Can you determine how many decimal places this uses? Can you estimate each of these 4 numbers? I will give you some time to do that yourself. If you need to, pause the video here so that you can work at these 4 problems. I will be going over the answers shortly. So pause the video if you need more time. All right, I am now going to go over the answers. So here we go. First off, we look at this tool. The numbers are just the tens place, 0, 10, 20, which means these dashes are the ones place. We then estimate the tenths or first decimal place. So 10, 11, 12, 13, 14, 15, 16 is what the tool tells us. But as we look here, it's over the 16. And that's kind of at that halfway point. But remember, this is a thermometer, so we consider it like it was mercury, and so we definitely make sure we measure that tippy tip. So 16.4, 16.5, all of that would be good. 16.3 is okay, but 0.4 and 5 is better because we have to assume that it is mercury. Although most thermometers we use in class will be alcohol thermometers, which do not bow up, but also bow down. If we look at violet, we are at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then as you see, this one also bows up, but it's slightly lower than the blue. Not much, but slightly. So something like 9.3, 9.4 would be good as opposed to 0.4, 0.5. 9.2 will be acceptable in most classes, but zero point 0.3 and zero point 0.4 are the best. Now green is right there on the line. So again, 20, 21, 22, and then your 0.0 because notice all of these have one decimal place. Now the hardest thing to do at all is negative temperatures. This is the absolute hardest measurement to take because you need to count backwards. So here's 0, then -1, -2. So it's definitely -2. And then as we count backwards here, well, you'll notice this hump, like most of the other humps, is below the halfway point. Normally that would mean less than 5, but we're counting backwards. So it actually means greater than 5 because we are counting backwards. It's a quirk with temperature. It's not fun, but it's what you have to do if you want to read a thermometer that's super cold well. And so -2.6 is the answer you should have. -2.6, -2.7, or -2.5 would all be good, but -2.6 is best. Lastly, we are going to, I almost got ahead of myself. Remember, one decimal place for every one of these measurements. Lastly, we are going to look at the graduated cylinders. Remember, meniscus bows down or it bows up. So you have to keep in mind the meniscus as you work. Again, I am going to give you a little bit of time for you to take care of this. I remember to measure in the direction of the meniscus, and that means under or overestimating in that direction. So I'm going to give you a little bit of time. Determine how many decimals you have. Determine what the numbers are. If you need to pause the video so you have more time, please do so. But I will give a little bit of space where I'm not talking, but then I will begin. But again, pause the video if you need to. All right, let's do this. Now, first off, the numbers are ones places. There are no dashes, so that means we're going to estimate the tenths or one decimal place. If I'm looking at blue, it bows down, but this really looks like it's in the middle. So I would say very confidently that this is 3.5. Now, if you did estimate, you would want to go 3.4 because it's bowing down, so you need to estimate down. Violet is different because it's bowing up. And we're definitely above 2, but not at 3, which means this is going to be 2 point something. And this line is clearly past the halfway point, more towards the 3. So this is definitely going to be something in the lines of above 5 and well above 5. But since it's not right up against the line, I don't think 9 is the best answer. 2.8 pretty much is the best answer here. If you have to estimate, I would do 2.9 beyond it, but I wouldn't. 2.8 is the best. It's really what it should be here. Like with many other times, green is right on the line. It's kind of a pattern that Mr. D chose to do. Now, if you look at this, it bows down, but it bows down right on that line. So again, 2.0 is correct. If you did do 1.9, I guess you could get away with it, but it's not very good. 2.0 is pretty much the only right answer here. 2.1 is very wrong because then you're not going in the direction of the bulge. Now, the red one is tricky. It's always the trickiest one here, always showing something odd. This one, you notice you have an upper limit, but not a lower limit. That's super bad. If you don't have a lower limit, then you should not take this measurement with this tool. Red is just going to be unreliable. But if the question asks you and you have no other choice, then you just have to do your best. It's clearly above 1, clearly not at 2, but definitely more in that direction. So definitely above 0.5. 1.7 is a good estimate for red, except not really because all red estimates here would be bad because you don't have a lower limit. Just go get a new tool. But if you're stuck, 1.7 is the best that you can do with the materials that were provided. This has been a quick course on measuring with Mr. D. Thank you for watching. And if you need to rewatch the video, go right ahead. Have it play in the background. Watch it as many times as you need to help you. Good luck, students. I wish the best for you and see you next video. Bye.